My name is Redo Meyer and I'm the tech lead for Google's Android Developer Relations team. One of the most effective ways you have at your disposal for optimizing the efficiency of your data transfers is eliminating user-driven updates. That means doing everything you can to eliminate the refresh button within your app. The most common reason people hit refresh is because they don't believe your app is displaying up-to-date information. And if you're using some form of client-side polling, they're probably right. In fact, every time you create a repeating alarm to ping your server to check for updates, Sundar kills a bug droid. Stop the slaughter and use Google Cloud Messaging to have your server notify your app when there is data ready to be downloaded, or even include the new data in the message payload itself. If you're using polling, you're forced to balance data freshness with the resulting battery drain. The more often you poll for updates, the lower latency between the data changing on the server and your app displaying those updates. But turning on the radio to check for those updates also drains the battery. That's the worst of both worlds when what you actually want is no latency and as little battery drain as possible. Google Cloud Messaging helps you do this by offering a way to send messages from your server to any installed instance of your app. As a result, you can stop polling, which will improve battery life and also improve the freshness of your app. Once configured, you can transmit messages to a specific app installation or multicast messages to multiple recipients. These messages can be simple tickles notifying your app that there is new data ready to download, or it can include the new data within the message payload. In this DevByte, I focus on how to use Google Cloud Messaging to perform more efficient data transfers. The details for setting up your GCM client and server are detailed comprehensively in the documentation. That said, it helps to understand the GCM data flow. It starts with your app on each device registering itself by sending a registration message to the GCM infrastructure. In return, it will be sent a registration ID, which uniquely identifies that instance of your app running on that particular device. Your app should then send this identifier to your server, typically along with a separate identifier that you can use to identify a particular user or installation. Your server now has a way to send messages to a specific app or a specific user via the Google Cloud Messaging infrastructure. Anything from breaking news, updated sports scores, new email messages, or an updated list of news articles. This is enough to eliminate the need for polling and ensures you never turn on the radio to communicate with a server that has nothing new to download. So your information architecture now needs to determine the urgency of reflecting each server change in your app. You can set up your server using either HTTP or CCS using XMPP and encapsulate payloads as JSON or plain text. Here we're using JSON to create a message starting with the registration IDs to which we want to transmit our message. By default, your app will receive GCM messages even if it's not running and the phone is on standby. You can help minimize battery drain by setting delay while idle to true, indicating that your message doesn't need to be sent immediately if the device is on standby. Instead, these messages will be queued until the device becomes active. In fact, if you also set a collapse key, only one message will be sent when the device does become active. The collapse key is any arbitrary string that the GCM servers can use to collapse a queue of messages addressed to the same device. So when the device comes online or becomes active, it receives only one message. There's no guarantee that the message the queue collapses to will be the most recent one you sent, so these messages are known as send to sync, and are best suited to update tickles that tell your app simply that there is new data ready to download. You can go a step further and set a time limit before queued messages expire using the time to live parameter. This determines how many seconds the GCM servers should keep a message before cancelling it. By default, this is set to 4 weeks, but you can dramatically reduce this for messages you know will be out of date or replaced over a shorter time period, which is a particularly useful feature for messages with payload data included in the form of an optional JSON object whose fields represent key value pairs of data. Each message can store up to 4K of data, which will be delivered as strings within the intent bundle of received GCM messages, as you can see here. These non-collapsible or message with payload messages are more than a sync tickle. They're used when you need to deliver every message because every message has different content. Notifications are a great example of how you may use these payload messages. By including the current weather details, commentary, and score after a touchdown pass or breaking news headlines and summaries within the payload of the GCM message itself, you're able to update your users immediately with nominal incremental battery impact. It is possible to use these collapse keys with payload messages, but because the delivery order isn't guaranteed and the collapsed message isn't guaranteed to be the last one received, you need to be careful not to display outdated information. If non-collapsible messages with payloads aren't going to provide a specific improvement to the user experience, send to sync messages are a better option as they put less of a burden on the device battery. For example, if your server notifies your app every time there is a new article or message, it only needs to receive one message telling it that it's time to sync up. which you can do using a sync adapter to initiate the sync, preferably bundling a number of batch transfers together as described in my DevByte on batching, bundling, and using the sync adapter. Using Google Cloud Messaging allows you to totally eliminate client-side polling from your applications. Implemented correctly, you can configure the messages transmitted to have as little impact on the battery as possible using techniques like short time to live parameters, collapse keys, and the delay while idle parameter to limit the number of messages that are actually transmitted to your app. By keeping your apps constantly up to date, you can minimize latency and help eliminate the refresh button. Used with sync adapters and prefetching, you can dramatically improve the battery efficiency of your apps.